Okay, so we can start. So today, this topic, the first topic that we're looking at is very short. So it's just the theory surrounding business statistics. It's just the foundation. Some of the concepts, maybe you've come across them in your other programs, but the information is virtually the same. Then after this, we're going to look at now the actual numbers, Yeah, so I'm going to split the lesson into two. So I'm going to look at lesson one first, then I'll cut the meeting, and then we're going to begin lesson two. I don't know if you are
Okay.
following. Yeah,
Yes, I'm following.
yeah. So for this first lesson, just getting an introduction to business statistics, and you're going to look at a
Okay.
few ideas relating to the definition of data and information and the characteristics of information and other fundamental factors. Otherwise, this is very simple specifically for theory. So sometimes an exam, it's not always calculations, but sometimes the exam can have some theory. You have to make sure you're ready for that theory as well. Okay. So the first thing that we need to look at is the distinction between data and information. So how do we, define data and how do we define information? So the simplest definition that you can come across with respect to data, this is just right facts that have not yet been processed. Right? So these are just facts that have not yet been processed. Thus, they don't have any organization, right, or any inherent meaning. So I've had an opportunity to perform some research, right? I was doing some research for World Bank. So we would go in the communities, we just collect data, right? So when we collect that data, in that moment, it doesn't really have any logical sense because nobody has interpreted it and nobody has organized it. But when we take that information to the head office, so at head office we've got the data analysts and then they make sense out of the data that we have. So now this takes us to the definition of information. So information is just data that has been processed, organized, and given context. So what usually happens when you're performing a research, data collectors, they go into the field, they collect the data. It doesn't have any sort of meaning, right? When it comes to head office, the data analysts, they review that data and then they create something that makes sense out of that data that the data analysts have collected. And thus, it has contextual meaning, right? And it becomes information. So people can read reports, right? So that's the distinction between data and information. Then we're going to look at the types of data that we have. So now we're going deep into data and we're looking at the types of data that we have. So we've got two types of data. There's qualitative data and then there's also quantitative data. So qualitative data from the definition itself, it's self-explanatory. It's descriptive, right? It's not expressed in form of figures, right? These are just qualities and characteristics. So there are no numbers whatsoever. This is just, from the context of qualities as well as characteristics. But now, quantitative data is more numerical, right? It deals with numbers, it deals with measuring, it deals with counting, right? And that's the major distinction between qualitative and quantitative data. So qualitative data is more subjective, right? It focuses on qualities and characteristics. But on the other hand, we've got quantitative data, which is more numerical, right? And deals more in
Mhm.
numbers. So now, we're now going to look at the types of qualitative data that we have. So data is classified into qualitative and quantitative, and then qualitative data is classified into two, and then quantitative data is also classified into two. So we begin by looking at qualitative data. So qualitative data can be organized in form of nominal data or ordinal data. So nominal data, this is just simply data that has been categorized into groups or labels without any inherent order or hierarchy. So you've got a group of characteristics, right? But they don't have any uh, order or hierarchy of some sort. right? This is just qualitative data that has been put together. So for instance, we've got gender. So we've got gender, it's male or female. Even though Americans, they try to bring in their own, confusion, but otherwise, it's either male or female. But now this data is just clustered together, right? It's not put in any form of order. So there's no one element of a class that's above the other. It's the same with race, right? There's white, black, and Asian. Then blood groups, there's A, B, C, or A, B, and O. So these are some of the examples of nominal data. And then now there's ordinal data. So I remember when I was performing these researches, so there's an aspect of qualitative research where you're asking the respondent, right, to rate their emotions, right, according to a specific range that you give them, whether they are satisfied, dissatisfied, very satisfied, neutral, all right, or just dissatisfied. So these are the things that we used to undertake when we are administering the questionnaire, all right. So now that type of data that has a series, right, uh, of
Mm-hmm.
ratings. So for instance, here we've got satisfactory rating. So there's got very satisfied, satisfied, neutral, dissatisfied, and very dissatisfied. So now this is ordinal data. It's qualitative, quite alright, but now it's in some form of order. So there's one aspect of the class which is lower than the other aspect. So this very satisfied, all right, it's slightly at the bottom side, right? So if it's putting them in numbers, you can say this can be 1, and then very satisfied, is on the upper end, so it can be 5. So this is qualitative data, but it has been arranged in some form of order, which allows for intervals, right, between those values. And then, mostly in the exam, they're going to be asked about quantitative data and the classes of quantitative data, right? So now, there's either discrete or
Mm-hmm.
continuous data. That is quantitative. So quantitative is classified into two. There's discrete and there's also continuous. So discrete data, it can be counted. That's the first characteristic. So even in the exam, you'll be asked to cite the characteristics of discrete data, right? It can be counted, right? It takes a specific value or range. For instance, the perfect example is you've got a classroom, right? A classroom can either hold 50 students, 60 students, or maybe 20 students or 30, depending on how that building was constructed. So the people in that room, the people that occupy that room, they can be counted by hand. You can just say, okay, there are 20 people in here. You just count. That's discrete data, right? So if there are 50 seats in the classroom, then means the limit is what? 50. Of course, people can stand in the room, but even though they stand still, you can be able to count the heads, right? And the other characteristic is it cannot be expressed as a fraction. So the people in a room, in a classroom, you can't say there are 40.5 people in a classroom. No. Another example, you've got a motor vehicle. A motor vehicle has got 4 wheels. You can't say the motor vehicle has got 4.5 wheels. No, that doesn't work. People in a bus, a bus holds about maybe 60, 62 passengers. You can't say there are 62.5 passengers in the bus. No, that doesn't work like that. So that's discrete data. So it's got a specific uh, amount that it holds, can be expressed as a fraction, and it cannot be expressed in smaller units, right? So the number of people in a class, you can't convert that number into a smaller unit. No, it's just 5 people, 10 people, and it ends there. But continuous data, on the other hand, right, it can be measured. So examples of continuous data, maybe you're measuring distance. So distance, you measure it. Weight, you measure it, right? Temperature, you measure it. So those are examples of continuous data. So weight can take up any amount. Weight can be 50, 50.5 kg, 30, 30.5 kg, right? It can take up any amount across a data range, right? And it can also be expressed as a fraction. Not only that, it can also be expressed in smaller units so that it can be easier to understand. So like distance, you've got kilometers. You can translate those kilometers into miles if you're in America. Then you can also change those units into meters, kilometers, centimeters. You know, so that's an example of continuous data. So I don't know if you have any questions so far.
No questions. But
Any question?
what do you mean when you say smaller units?
Small. So for instance, when we have distance kilometers, right?
Hmm.
So those kilometers they can be translated into a smaller unit, let's say centimeters.
Okay.
Yeah, that's
So that's a similarity between the discrete and continuous that
so
they
that
have
that's
in common.
that's the difference, because discrete cannot be translated into smaller units.
Or
Okay. Oh yeah. So I think this
because I
was
was
just
looking at
where I get where you're coming
okay,
from. Yeah. So this is a type where it's supposed to be cannot be expressed in smaller units. Yeah, my apologies for that. I think I'll
okay,
rectify it before I send the notes.
okay.
Okay, so these characteristics when we're looking at financial accounting, these are the same characteristics of good information that we're looking at now. So remember, there's accuracy, which simply speaks to correct and free from error information. Relevance, information is supposed to be pertinent to the situation or problem at hand, right? So if someone needs
Mhm.
a certain class of information, they need information about you know the the distance. You can't give them information about the weight of an item, so it doesn't make sense, right? So
Mhm.
relevance is information is supposed to be pertinent. Timeless information should be presented when needed and not outdated. Completeness, all necessary information should be included and not and no relevant details should be missing. Understandability, these are the same concepts as we looked at in financial accounting. Information should be clear and easy to comprehend, avoiding jargon and technical terms. Reliability, information should be trustworthy and should come from credible sources. From the perspective of financial accounting, audited financial statements, they are reliable. Then accessibility,
Mhm.
information should be easily obtained and available to the intended audience, right? Then concise simply means, brevity of information. Information should be brief, to be straight to the point, all right? And you should avoid unnecessary detail. Because even in the exam, sometimes you're told you just have to go to the point. Don't write irrelevant information. At the end of the day, you're marked based off the points that you're able to stress in the exam. Then lastly, we're going to look at just some additional definitions. There's population. This is the entire group, right? Entire group of data where you want to draw the conclusion. So population is the whole group. So if I remember, we were carrying out this World Bank survey in collaboration with a government ministry, Ministry of Social Welfare, right? So
Mhm.
it's actually, I think, community development or something. So the population of data that we had was women from I think Luapula province, right? Now from that population of data, we had to select a few individuals that were going to interview. So these were women who have never been to school, right? These are women
Mhm.
like who have an idea about business, right? So out of all the women in Luapula province, we had to select a specific group of people that we're going to interview, right? And that's a sample. So a population is the whole data set, and then the sample is just a specific group out of that data set where you're going to you draw the data that you want. Then the other idea that you need to come across is skewness. This simply measures the asymmetry of a distribution. So to avoid all this jargon, I'll just try to draw something so that you understand the skewness. So what skewness simply means, right? So
Mhm.
this is how close, right, this distribution is to zero. So this distribution of data, how close is it to zero, right? So if it goes to the left, it's left skewed, or it skews leftwards. Then if it goes to the right, it skews rightwards. This is the basic idea of what skewness is, right? This is the asymmetry distribution of data, right? And distribution can either be right, right, or left, right? So actually, this is when it goes this side, skews this side. This is left or negative. Then when it skews this side, this is right or positive. In an exam, you won't really be asked about skewness, but you just have to have the idea. I don't know if you have a question from what we've done so far.
No questions.
Yeah. So from the perspective of the exam, the Zika exam, you can be asked section A to just cite a few characteristics here and there. Section B, you can be asked to differentiate between discrete and continuous data, right? And you can also be asked to explain the characteristics of good information. Right. So with that said, our lesson has come to an end. So I think we just have a short break of maybe 20 minutes, and then we'll begin the other lesson.
All right. I'll be waiting for the. We'll use the same link.
No, I'm going to end this one, but I'll send the other link.